dear students, today I am here to explain some of the very important concepts in electrochemistry are electrolysis, Faraday law of electrolysis and electrochemical equivalents and application of electrolysis and batteries. So these are the very important concepts in electrochemistry. Okay. Here Faraday law of electrolysis. Here Faraday first law and Faraday second law. In these two, one question is very important question. Means it may be Faraday first law or it may be Faraday second law. Okay, definite questions in your theory and your examinations. And batteries. Here also in batteries there are two type of batteries. First one is primary battery and another one is secondary battery. Here reactions is very important. Means primary batteries reactions and the secondary batteries reaction. So student, first one electrolysis. Okay, let us start with the electrolysis. Before going to start this one electrolysis concept, you are familiar with the some of the important concepts in electrolysis are cation, anion and electrolyte. So first one, what is meant by cation? Cation means a species which can donate an electron and become a positively charged, or you can say a positively charged species is called a cation. And what is meant by anion? Anion means exactly opposite to the cation, means it gains one electron and become negatively charged species, or you can say anion means negatively charged species are called anions. And what is meant by electrolyte? Electrolyte means a substance which split into ions. A substance which split into ions in molten state or in a dissolved state by passing electricity. Student, electrolyte. For example, you can take electrolyte as a NaOH or a KCl or HCl, whatever it may be. KCl, HCl. For example, you can take HCl. First one, HCl. When you pass the electricity to this HCl, it splits into ions like H plus and Cl minus. Here H plus is a cation, Cl minus is a anion. Means here hydrogen it loses one electron and chlorine it gains one electron and they become cation and anion respectively. Now electrolysis is what? Next one. You already know some of the important terms like strong electrolyte, weak electrolyte and non-electrolyte in your previous classes. So student, what is meant by strong electrolyte? Strong electrolyte means the substance it is completely dissociated into ions. The strong electrolytes are, these are the strong electrolyte. HCl, KCl and H2SO4, HNO3, these are strong electrolytes. These are strong electrolytes. Means they dissociate completely. And weak electrolyte means they dissociate partially. Weak electrolyte means they dissociate partially. Example for weak electrolytes are acetic acid, CH3COOH and NH4OH, ammonium hydroxide. These two are the example for a weak electrolyte. And one more, non-electrolyte. Non-electrolyte means the substance which do not dissociate completely. Example, urea, glucose and distilled water. So student, our aim is to discuss about strong electrolyte and a weak electrolyte. Whatever it may be. It may be strong or it may be weak, but not a non-electrolyte. So first one, electrolysis. In this electrolysis, cation means positively charged species, anion means it is negatively charged species. During electrolysis, cation move towards cathode, anion move towards anode. Right? Okay, in the first one, electrolysis. Let us start with the first concept, that is electrolysis. First one, electrolyte. First one, electrolyte. What is mean by electrolyte? Electrolyte means, here the definition of electrolyte. Electrolyte means a substance which splits into ions, a substance which split into ions in molten state, or in dissolved state, a substance which is split into ions in molten state or in a dissolved state by passing electricity. And you can say in your language or in your word sentence, by passing electricity, the substance which split into ions are called an electrolyte. So I already explained there are three type of electrolytes are there: strong electrolyte, weak electrolyte, and a non-electrolyte. And next one, electrolysis. What is meant by electrolysis? So student, electrolysis means the process in which on passing electricity, electrolytes are split into ions. I will repeat it once. Electrolysis means the process in which on passing electricity, electrolyte split into ions, then the ions deposited at oppositely charged electrons. Just imagine student, this is the electrolysis method. Here I am going to take one is cathode and the other one is act as the anode. Here one is act as a cathode and the other one is act as a anode. Means in a galvanic cell or in a simple electrolysis cell, cathode reduction reaction takes place, in anode oxidation reaction takes place. So this is the electrolyte. On passing current to the electrolyte, here cations move towards cathode, anions move towards anode. Cation move towards cathode, anion move towards anode. The process in which on passing electricity, electrolyte split into ions and ions are deposited at oppositely charged electron. That is called electrolysis. I will write here the definition for electrolysis. Here, the process in which on passing electricity, electrolyte splits into ions and ions deposited at oppositely charged electrons. It is called electrolysis. Student, electrolysis means the process in which on passing electricity, electrolyte split into ions and ions deposited at oppositely charged electrons. This is known as electrolysis. And next, application of electrolysis. Application of electrolysis are electroplating and electrolytic refining, and it is used in the extraction of metals and purification of metals, and electrotyping and electroprinting. So they are the examples of electrolysis. So take it down: electrode and electrolysis. Next one is a very important concept in electrochemistry, that is Faraday's law of electrolysis. Faraday's laws of electrolysis. Faraday's law of electrolysis. Student, for your in your syllabus there are two laws are there. Faraday first law of electrolysis and Faraday second law of electrolysis. In these two, Faraday first law and second law, what is very important for your theory annual examination? So here I am going to write a first one, Faraday's first law of electrolysis. 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 The definition on the statement of a Faraday first law of electrolysis is, during electrolysis, this is the statement and very important statement, Faraday first law, very important for a 2 marks question. During electrolysis, during electrolysis, the amount of ions during electrolysis, the amount of ions deposited or liberated at an electrodes is directly proportional to the quantity of electricity passed through electrolyte at a time t. Students, I will repeat it once. During electrolysis, amount of ions deposited or liberated at an electrodes is directly proportional to quantity of electricity passed through electrolyte at a time t. So here, first one, amount of ions you can consider W or M, means mass of ions or weight of ions. W, weight of ions, is amount of ions deposited or liberated at an electrode is directly proportional to quantity of electricity passed in a time t. W is directly proportional to I into T. Yes, I means the current in time t. So I, we can write I is equal to Q by T. Student, I means it is a current, right? Current is equal to charge flow by time. Then just rearrange this equation. I is equal to Q by T, right? I means current means charge flow by time. So rearrange this equation. Q is equal to I into T. Just substitute this value in this one. W is directly proportional to Q. And W, just remove this directly proportional sign and you will get a proportionality constant. W is equal to ZQ. W is equal to Z and Q. Here student, W means where? W means amount of ions deposited or liberated at an electrodes, and Z means it is proportionality constant. W is a proportionality constant, or you can say electrochemical equivalent. Electrochemical equivalent. ECE. Electrochemical equivalent. and Q means quantity of electricity passed, that is I into T. So this is about Faraday's first law of electrolysis. During electrolysis, the amount of ions deposited or liberated at an electrode is directly proportional to the quantity of electricity passed through electrolytes. Amount of ions W is directly proportional to quantity of electricity passed in time t. Here I, nothing but current. Current is equal to charge flow by time. So I is equal to Q by T. So rearrange this equation, you will get a Q is equal to IT, and W is directly proportional to Q. We can write like this. And W, just remove this directly proportional sign and you will get a proportionality constant, that is electrochemical equivalent, that is ECE. W is equal to Z into Q, where W is amount of ions deposited or liberated, Z is proportionality constant, and Q nothing but it is a charge flow into time. So this is about Faraday's first law of electrolysis. Take the notes. Next one, students, Faraday's second law of electrolysis. Faraday's second law of electrolysis. The statement of Faraday's second law of electrolysis is when same quantity of electricity passed through two or more electrolytes connected in series. When same quantity of electricity passed through two or more electrolytes connected in series, then the amount of ions deposited or liberated at an electrodes is directly proportional to their chemical equivalent. So this is the Faraday's second law of electrolysis. When same quantity of electricity passed through two or more electrolytes connected in series, then the amount of ions deposited or liberated at electrodes is directly proportional to their chemical equivalent weights. W1 here, W1 weight of ions, W1 is directly proportional to E1 and W2 is directly proportional to E2. So here W1 and W2 are the weight of the ions, and E1 and E2 are the equivalent mass or equivalent weight of the electrolysis. So here W1 by W2 is equal to E1 by E2. This is the mathematical expression for a Faraday's second law. W1 by W2, E1 by E2. And this is the diagrammatical representation of Faraday's second law. So just consider this is a one half cell reaction, and it is a one half cell reaction and another one half cell reaction connected in series. Here cathode, anode, cathode, anode, cathode, anode, cathode, anode, cathode, anode, cathode, and anode. For example, you can consider this is ZnSO4, this is CuSO4, this is AgCl2. This is AgCl2. Means here electrolyte I am going to take in this series are ZnSO4, copper sulfate, and AgCl2. So this is about the third second law of electrolysis. When same quantity of electricity is passed through the two or more electrolyte connected in series, then the amount of ions deposited or liberated at an electrode is directly proportional to their chemical equivalent weights. So the very important concept, third second law of electrolysis. Take the notes. Next one more concept in electrochemistry, that is batteries. Batteries. Student, batteries. What is meant by batteries? Batteries, these are the source of electrical energy. Here, it is a type of galvanic cell. Chemical energy of redox reaction is converted into electrical energy. Means battery is nothing but they are the source of electrical energy, and chemical energy of redox reaction is converted into electrical energy. Means here chemical energy input, and it gives the electrical energy output. Electrical energy output. Student, chemical energy input, electrical energy output, or you can say chemical energy of a redox reaction is converted into electrical energy. So these are the galvanic cell. Yes. Here batteries. These are the batteries are the source of electrical energy. Source of electrical energy. Source of electrical energy. And students, batteries means they should have a common characteristics. They are, first one, batteries they should light in weight, and they should compact and constant voltage. So these are the condition for batteries. They should be light, they should compact, and they should have a constant voltage. And students, batteries, there are two type of batteries are there. One is primary battery and another one is secondary battery. Primary batteries means they are used only once, and they cannot be recharged. And secondary battery means they rechargeable batteries are called secondary batteries. Here students, batteries are two type. One is primary battery. Second one is secondary batteries. Batteries are divided into two types: primary battery and a secondary battery. So in here, primary battery means they used only once, and cannot be recharged. Examples for primary batteries are, primary batteries are used in transistors, clocks, wall clocks, and torches. Primary batteries, example for a tri-cell or a Leclanche cell. Yes, they are used in transistors, clocks, or torches. So first one, in primary batteries. Okay, here I am going to discuss about only primary battery. Primary battery means they used only once and cannot be recharged. Examples for primary batteries are a tri-cell and a mercury cell. They used in transistors, clocks, and torches. Here, example for primary batteries. There are two examples are there. First one is dry cell, or you can say the Leclanche cell. Dry cell, or you can say Leclanche cell, means like we are using a everyday cell, that is called a dry cell. Means it cannot be recharged, but it is only used only once. And second one, mercury cell. It is used in a common watches. First one, dry cell. So here reactions are very important. First one, dry cell. Dry cell. Dry cell means it is used in clocks and torches. Dry cell. Here I am going to draw a small diagram about dry cell. So dry cell, it is consists of a zinc cylinder. Here a graphite rod is surrounded by a zinc plate which is act as anode. Here zinc plate which is act as anode, and here this is graphite rod which is act as a cathode here, which is act as cathode. So here in between cathode and anode some place is filled by the substance like or paste like NH4Cl, ammonium chloride paste is filled in the between zinc and graphite or cathode and anode. And graphite, it is made up of carbon and one more substance, carbon and MnO2 powder. Cathode is made up of carbon and MnO2 powder. So this is about the dry cell. Here this is cathode, here anode. Anode is made up of zinc and cathode is made up of carbon and MnO2 powder. And in between cathode and anode, a small gap is there. That gap is filled with the help of a paste like ammonium chloride and zinc chloride. So here reaction. Here anode and cathode reaction takes place. First one, anode reaction. So students, in last class we already discussed about cathode and anode reactions. In anode, oxidation reaction takes place. In cathode, reduction reaction takes place. So first one, anode. Here, which is the anode? Zinc. In anode, always oxidation reaction takes place. So anode, zinc, it loses 2 electrons and it becomes Zn2 plus, because here oxidation reaction takes place. And cathode. Here, what is the cathode, students? Carbon and MnO2 powder, and NH4Cl also there. So here MnO2 manganese dioxide powder plus NH4 plus, it gains 1 electron because in cathode reduction reaction takes place. I will write here MnO2 plus NH4 plus and it gains 1 electron and become MnOOH plus NH3. This is the cathode product. MnOOH plus NH3. This is the cathode product. And student, here the ammonia is produced in this reaction. Ammonia is produced in this reaction is reactive with zinc and they form a zinc complex, zinc ammonical complex, that is ZnNH3 4 times. ZnNH3 4 times. So this is the complex formed during the reaction. And this dry cell has a potential value that is 1.5 volt. The dry cell has a potential value that is 1.5 volt. It is constant. 1.5 volt. It is constant. So student, here it is a dry cell. It is an example for a primary battery. There are two reactions that happens here. One is an anodic reaction and the one is cathodic reaction. In anode, oxidation reaction takes place. In cathode, reduction reaction takes place. In anode, zinc, it loses 2 electrons and becomes Zn2 plus. And in cathode, MnO2 react with NH4 plus and it gains 1 electron and they become MnOOH and it produces ammonia. So here the produced ammonia is react with the zinc and they form a complex. And last one, the dry cell has a potential value that is 1.5 volt. So this is about dry cell primary battery example. Take it. Next one, students. Second example for a primary battery, that is mercury cell. Just imagine it is used in a watch, a small mercury cell. Here, anode is zinc. Here, anode is zinc, or you can say zinc is act as an anode, and mercury oxide HgO, it is act as a cathode. HgO act as a cathode, and here electrolyte is used. Electrolyte is used in this mercury cell is KOH. KOH. So student, the reactions are anodic reaction in mercury cell. Anode, it is made up of zinc. Means here zinc, it loses 2 electron, it becomes Zn2 plus by losing 2 electron. Means in anode oxidation reaction takes place. And in cathode, HgO, it gives rise to mercury. Okay, reduction reaction takes place. Okay, and electrolytes here used as a KOH. By using this, we can rewrite the anode and the cathode reactions. Like the first one, anode, means we are in this reaction we are going to use the electrolyte. Anode oxidation reaction takes place. Here use a Zn plus electrolyte, that is 2OH minus. It gives rise to ZnO, because here in anode oxidation reaction takes place, addition of oxygen to the zinc. Zn plus 2OH minus, it's become ZnO plus H2O plus 2 electron is released. This reaction. Okay, here this is a common reaction, but here we are going to use a electrolyte. Zn plus electrolyte, that is KOH, means K plus OH minus, that is why I am going to take up 2OH minus. Zn plus 2OH minus, it's become ZnO plus H2O, and it releases 2 electron. And cathode reaction. In cathode, reduction reaction takes place, right? Cathode. Here, which is the cathode? HgO plus H2O, and it gains 2 electron and become mercury, Hg plus 2OH minus. 2OH minus. This is the cathodic reaction. And the net reaction or overall reaction, just remove this 2OH minus, cancel each other, 2 electron, and H2O. Then what is the remaining, students? Here Zn plus HgO gives rise to ZnO plus Hg. And mercury cell has a potential value, that is 1.35 volt. The potential, or the battery has a potential value. The battery has a potential value, that is 1.35 volt. 1.35 volts. So this is about mercury cell. And dry cell and mercury cell, these two are the example of primary batteries. Take it.